In a moment that stunned the tech world, Nvidia's CEO just made a statement that shocked everyone. Speaking off script during a private summit, he hinted at something Elon Musk is working on, something so advanced, so disruptive, it left even Nvidia's top engineers speechless.
From the moment of concept to building a massive factory, liquid-cooled, energized, in the short time that was done, that is like superhuman.
What did he see? What does Musk know that we don't? But to understand what really happened, we need to go back to when it all began. It started with the birth of something powerful, and a quiet company called xAI. The birth of Colossus and the rise of xAI. It began quietly. No media blitz, no flashy unveiling, just a forgotten piece of land in Memphis, Tennessee. A former Electrolux manufacturing site, rusting from years of inactivity, was suddenly swarming with workers. Within days, the world found out why. Elon Musk and his AI company, xAI, had chosen this unassuming spot to launch something audacious, the largest, most powerful artificial intelligence supercomputer ever built. They called it Colossus. And the name wasn't just for show. Musk had promised speed, power, and scalability unlike anything the tech world had seen. But what followed still caught everyone off guard. In just 19 days, less than 3 weeks, Colossus was not only standing, it was running. That timeline bordered on science fiction. It wasn't just a warehouse full of servers. It was a liquid-cooled, high-density, energy-hungry fortress of data. Engineers had to coordinate around the clock. Permits, cooling infrastructure, electric capacity, everything had to come together almost instantly. Somehow, it did. By the end of 2024, Colossus had become more than a tech headline. It had become a symbol of what was possible when vision, capital, and relentless execution align. Nvidia CEO Jensen Huang, someone who's seen the bleeding edge of technology for decades, called the entire project superhuman. And that wasn't some offhand compliment. He knew the scale involved. He knew the logistics. Huang had every reason to be skeptical, but even he had to admit what Musk pulled off was beyond normal. The way Huang told it, there's only one person who could make something like this happen under such pressure, and that was Elon Musk. It was a rare moment of admiration from one titan to another. Musk wasn't just building a supercomputer, he was challenging the status quo. While other AI labs were battling over cloud contracts and incremental improvements, Musk was laying the foundation for something much bigger. At the core of this beast were over 100,000 Nvidia H100 GPUs, the fastest, most expensive AI chips on the market. Just sourcing that many would have taken most companies over a year. For Musk, it was a matter of weeks. Every piece of Colossus was meant to leapfrog the competition. The networking, the cooling systems, the software, all designed with scale and acceleration in mind. Where most AI clusters are built to support one model at a time, Colossus was made to train dozens in parallel. But this wasn't Musk's first dance with Nvidia. Their relationship went back years. Tesla's early versions of autopilot relied heavily on Nvidia chips. SpaceX used them for simulations. Even Neuralink depended on Nvidia hardware to help decode neural signals. Musk had worked closely with Nvidia's technology long before xAI was born. But this time, the stakes were higher. xAI wasn't just a partner. It was now a full-fledged competitor, challenging the very clients Nvidia had been serving for years, including Google, Meta, and OpenAI. Despite that, Nvidia didn't hesitate. They kept supplying Musk, even though every H100 chip that went into Colossus was one fewer for their other customers. Why? Because what Elon was building wasn't just impressive, it was necessary. For Nvidia, backing Colossus wasn't just a business decision, it was a bet on speed and ambition. In a world where AI development moves at a crawl due to compute bottlenecks, Elon was offering something different: velocity. Colossus also represented something else, an inflection point. Until now, the conversation around AI has been mostly about software, algorithms, ethics, and language models. But this project shifted the spotlight back to hardware, infrastructure, and raw compute power. Musk had thrown down the gauntlet. If you wanted to lead in AI, you couldn't just write better code. You needed to build bigger machines. That's the part everyone is now scrambling to catch up with. Of course, the big question still lingers. What happens if Colossus works? Not just as a data center, but as a learning engine, a system capable of ingesting the world's knowledge at unprecedented speeds. Musk says the goal is to understand the universe. But with that kind of power, Colossus could influence everything from medicine to geopolitics to automation. And for the first time, it's no longer just theoretical. The machine exists, it's alive, and it's learning. So, what is the future of AI now that Colossus is online? That remains to be seen. But one thing is clear, the rules of the game have changed. Engineering marvels and Grok's intelligence. XAI was no longer some Silicon Valley moonshot. It had become a full-fledged mission, grounded not in theory, but in steel, silicon, and steam. The Memphis facility, once just a remnant of the past, was now a monument to the future. Elon Musk wasn't just trying to build the fastest AI, he was redefining what a supercomputer could be. The Electrolux plant had been stripped down to its bones and rebuilt from the ground up with a singular purpose: to host Colossus. Inside those walls, there was no room for waste or hesitation. Every inch of space had a job. The structure had been retrofitted with a nervous system of cooling pipes, fiber optics, and electrical conduits, all supporting a massive internal ecosystem. This wasn't a typical data center. It was a living machine, pulsing with electricity and information. Thousands of high-performance racks filled the warehouse, each a dense forest of processors humming with anticipation. Colossus was less of a building and more of a computational city, buzzing with controlled chaos. The server racks were equipped with the latest Supermicro 4U GPU servers, each stacked with 8 Nvidia H100 units. Multiply that across row upon row, and the scale becomes staggering. One rack held 64 GPUs, and Colossus held thousands of them. These weren't general-purpose chips either. The H100s were engineered from the ground up for one thing: deep learning. They could chew through neural network calculations like nothing else on the planet. Cooling them was a challenge all its own. Standard fan-based systems would have melted under the pressure. So, engineers turned to liquid cooling, embedding the entire system with cooling distribution units designed with surgical precision. These CDUs, developed partly by Boyd Corporation, kept the thermal output in check by circulating coolant across carefully laid channels. The result? Even when operating at full capacity, the GPUs remained in their optimal thermal zone. The hiss of flowing coolant and the low hum of server fans replaced silence, becoming the heartbeat of Colossus. Of course, keeping all of this powered required an absurd amount of electricity. Over 100 megawatts flowed into the facility, enough to power tens of thousands of homes. The Tennessee Valley Authority approved this massive draw, recognizing the project's strategic importance. And it wasn't just the consumption, it was the consistency. Any fluctuation could lead to critical failures, so redundant systems were deployed, ensuring that power was never a limiting factor. Even more critical was the internal network. Connecting that many GPUs without latency was like trying to wire an entire city to think as one. That's where Nvidia's Spectrum X Ethernet fabric came in. Each node was linked by 400 gigabit per second connections, minimizing bottlenecks and allowing seamless data flow between processors. This fabric became the neural web within Colossus, letting the machine function like a single organism, not 1,000 independent parts. Jensen Huang was one of the few who truly grasped what was happening. He didn't call Colossus a data center. He called it a factory, an AI factory. That framing was perfect. Colossus wasn't producing cars, phones, or appliances. It was producing intelligence, churning through information, turning code into knowledge, and knowledge into models. It was the assembly line of the mind. And at the center of that production line was Grok. Grok wasn't just another chatbot. It wasn't built to imitate human speech or spit out answers like a parrot. Musk called it a reasoning AI. That meant it didn't just process data, it thought through it. When a user submitted a query, Grok didn't tap into a single server. It triggered a complex cascade, activating thousands of GPUs at once. These units worked in parallel, applying chain-of-thought algorithms that mimicked human reasoning, step by step. Unlike other AI systems, Grok could hold context across longer conversations. It could remember what was said 5 prompts ago. And it could challenge flawed logic, dig deeper into ambiguous questions, and even reflect on its own responses. This gave it a kind of personality, sharp, unfiltered, sometimes unsettlingly honest. Where other AIs tried to be polite or agreeable, Grok leaned into truth-telling, even if it made people uncomfortable. Its design allowed it to improve with every interaction. Feedback wasn't just collected, it was integrated into memory systems that adapted over time. This wasn't static software. Grok evolved. Each conversation made it better, faster, and more precise. The idea wasn't to build a machine that mimicked intelligence. The goal was to build a machine that became intelligent. Colossus wasn't simply training Grok. It was becoming the physical mind Grok inhabited. And if it worked, this would change what we expect from AI forever. Blackwell, Tesla, and the global AI arms race. Grok was already astonishing, but Musk wasn't known for stopping at good enough. Even as Colossus hummed through terabytes of data, another phase was already in motion. In late 2024, Musk announced the next leap, a doubling of Colossus's capacity. But it wasn't just about more GPUs. It was about better ones. The current powerhouse, Nvidia's H100, was about to be replaced by its more powerful sibling, the Blackwell H200. These weren't just upgrades, they represented a shift in what AI hardware could achieve. The H200 and its more advanced cousin, the GB200 NVL72 cluster, were engineered to deliver up to 60 times the performance of the H100 under specific workloads. For context, a model that once took weeks to train could now be trained in a matter of hours. It was like replacing a fleet of sports cars with fighter jets. But scaling at this level came with its own turbulence. Early tests of Blackwell chips revealed a surprising flaw: overheating. Not just minor temperature bumps, but major performance throttling that risked frying entire server racks. Nvidia's engineers scrambled to redesign airflow systems and optimize cooling protocols. It was a high-stakes race against the clock. Delays trickled in. Shipment dates shifted. Critics pounced. Wall Street didn't stay quiet. Nvidia's stock dipped. Musk's plans were suddenly in question. Had he overpromised? Was this just another case of visionary ambition outpacing reality? But Musk didn't flinch. His response was simple: it's worth the wait. And with the kind of long-term vision he's known for, he pressed forward, fully committed to Blackwell's potential. For him, this wasn't about one project or even one company. It was about building the future, no matter how long it took. Meanwhile, over in Texas, Tesla was staging its own AI revolution. While Colossus trained Grok to master reasoning and language, Tesla was busy refining the brain of every car on the road. At its Gigafactory, a new GPU cluster was quietly taking shape. A 50,000-chip powerhouse built specifically for training Tesla's full self-driving systems. The goal: to perfect autonomy, to reach a point where Teslas could navigate cities, highways, and backroads without ever needing a human behind the wheel. The supercomputer at Tesla wasn't just crunching numbers. It was absorbing petabytes of real-world driving footage, traffic lights, unpredictable pedestrians, bad weather, and accidents avoided by a second. It was a feedback loop from the road to the lab and back again. Tesla's Dojo system had already made waves with its custom chip design, but Musk doubled down by integrating Nvidia's GPUs into the mix. In fact, by early 2025, Tesla's GPU count was set to swell from 35,000 to 85,000, an astonishing escalation. And yet, controversy was never far behind. Internal documents revealed that 12,000 GPUs originally earmarked for Tesla had been redirected to Musk's social media venture, X Corp. The backlash was swift. Critics accused him of robbing Tesla to prop up his personal empire. Investors questioned his priorities. But Musk brushed it off. Tesla, he argued, wasn't ready to deploy those chips anyway. They would have sat idle. His bigger point was about flexibility, using his hardware ecosystem dynamically across his companies. To Musk, it wasn't about silos. It was about synergy. Advances made in Grok could inform Tesla's AI. Lessons from the self-driving world could sharpen Grok's reasoning. Neuralink could benefit from both. In his mind, it was all connected. And Grok itself had already started branching out. It wasn't confined to xAI's servers anymore. It showed up in Tesla dashboards, providing real-time feedback and predictive driving suggestions. It assisted businesses in automating workflows, sifting through data, drafting reports, and even running complex simulations. In some Neuralink trials, Grok was being tested as an interface, bridging brain signals and digital commands. It wasn't just intelligent, it was adaptable. The AI race was no longer academic, it was geopolitical, and as Grok grew smarter, Tesla moved closer to autonomy, and Colossus prepared to evolve once again. A question remained in the air, one that no machine could answer just yet. So what happens if Musk actually pulls this off? Colossus isn't just a supercomputer, it's a glimpse into the future Musk is racing to build. From language models to self-driving cars, the pieces are falling into place. But with so much power centralized in one man's vision, we have to ask, is this the dawn of something extraordinary? Or the beginning of something we can't control?